hopefully it will help you remember some of them. So moving forward, today we're talking about input and output. Okay. And so the input and output is not the core part of the language. That's why when we use it, we always have to call for the standard I/O library, right? But it's a very, very useful one. And this way make the C language very portable across system, because for different system, we could use a different standard I/O library. Okay, this is how you include the standard I/O library, which you have done. Well, not necessarily done, but you have seen that many, many times. We didn't actually ask you to compile any of your code, or if you use IDE, IDE will compile it for you. But this is just to show you how a compilation works with standard library. So you have CC, which is compile a C program, and your source file and whatever other things needed. And then you use a flag, okay, to indicate you're calling this standard library. This is only example if you're using a particular system, okay, not necessarily applicable to every modern computer. All right, so the most common one we have been using so far is getchar, right? And putchar maybe. Getchar is reading one character at a time. That's, again, it's very, very common. It's no surprise. You define an integer and you get it. Okay. Now let's look at some advanced usage of those. So previously, when we had getchar, then you run the code, then you have this terminal open. You have to type something inside, right? So instead of letting user type something, alternatively, we can use this symbol, like the smaller sign, and add a file name after that. That means whatever string or whatever text in that file will be entered into your program. Okay, this is very convenient, because now when you run your program, you can just simply attach whatever a file you want to process, right, after that, rather than you hard type every time into your command line. All right, so again, you use this smaller sign with your file name, and the string inside your file will be received by your getchar command in your code. Okay. The other way is we can pipeline multiple programs together. Okay, what does that mean? So in this first program, this is other program. In this first program, they might actually use putchar or print or whatever other things to output information into the terminal. Okay, but using this bar in between, and then your new program, all those outputs will be considered as input to your new program. All right, so everything this first program is supposed to print on the screen, now it's going to the second program is considered as entered into the terminal. All right, so this is very, very convenient method, and it is possible that you can make your code very, very portable, right? Imagine you have one program only lowering all the letters in a file, right? Then you send it to another program. The only thing to do is to count the frequency of every word in this program, right? Then the third one will be maybe extract the top highest frequently word, and maybe write an email, whatever, something like that. So you can make them as like a module. Then you almost like playing Lego, right? You just do this step first, second step next, and last step that. So again, this makes things very, very easy, and you don't have to write a new program every time you want to just process something a little bit different in a step. Yeah, so as we mentioned, we might also need to use the putchar, which is to output information onto the screen or terminal, right? The output could go to terminal directly, or it can go to a file. Okay, now using the greater sign, and then that will be sent out to the file itself. Yeah, again, this file interaction make your life very easy because in your code there you don't have to handle any file management, right? Traditionally, you have to open the file, get a pointer of the file, and then you process it using that pointer, and finally you close the file, right? Everything has been done by this standard IO library, so you don't have to worry about it. Pipeline, we just talked about that. The other output will be the printf, right? Like other than the put character. The printf is for printing obviously longer outputs. Note that those two outputs will all go into the same destination, so they might mix up. Okay, let's say in your code, one line is put character, another line is printf. Then both of them will be output to the other program if you use this pipeline method. All right, so let's see an example. So this particular code is to lowercase input, right? So we use a get character and use a while loop, and that means we keep receiving get character from whatever input we're receiving from, and then we just convert it into a lowercase, right? After we convert it into lowercase, we output it using put character. Okay, now that's it. So this entire thing become a module. It will always lower the case for the input of your file. So let's say later on, we're going to process some other file using some other program. This cat is another program which is to append file to each other. Like let's say you have two files separately, the cat will add them up into one file, all right? And then this program's output will be piped into your lower program, right? What that do is you lowercase every single letter in those two files or in this combined files. And then finally, you save the result into this output. The output is just the name of your file, okay? So by doing this way, you're actually doing multiple operations, like reading two files and put them together into a string and lower every letter in the string and output them to another file. Right, again, there's no code you have wrote so far to manage a file. The standard IO will manage that for you. By the way, we'll talk about this cat function a little bit later. By the way, in the standard library, the get character and put character is actually not a function. They're actually macro. The point of using macro is to make your code efficient. Okay. Anyone can tell me why a macro is more efficient than a function?
We avoid the function of the call function overhead.
What kind of overhead?
To call the function. So
yeah,
because it's already written in the header.
I know, but that my question is what type of overhead we were talking about here? Like what exactly the overhead is?
I'm not sure I understand the question, but whenever you need to call a function, there is a overhead because you need to you need to find the function and execute it. So it's less efficient that if you already have the code written in the header that
Okay.
is already saved, and you don't need to go find the function and execute it.
Okay, thank you. Yeah, that's partially correct. So she was saying, if you didn't hear, she's saying like you have to allocate that function in your memory and execute it, right? Okay, that makes sense. The other part of the overhead is if you're passing variables, right? Because obviously for a function, you often need to pass variables. Either it's a pointer or it's like a variable, an integer or floating point. You're making a copy of it, right? And you send it to the function, you do all the process, and you send it back, another copy coming back, right? So that's another type of overhead. Versus if we're talking about macro, the compiler will replace the whole thing with whatever code necessary to finish this process. So there's no finding function or making copy of variable happening during that time. Okay, so other than the put character, the printf is the most frequently used function, which will print a string as long as you want. And previously, we only used the printf bracket with whatever string you want to print in between. But now we're talking about the more sophisticated use of it. Means after the first string you have input, you can add arguments after that to format how you want to present a variable. Okay, you must already know that kind of idea. So, but here are some examples. We'll go back to this slide a little bit later, but let's look at the examples first. So here, for example, we have a floating point, and we're going to print it out using the %f, right? That will print out our results in a fixed point, floating point, which is often based off the system, but most of them are like having six digits after the point here. Okay. So this is how you change the output style of it, right? And here are some grammar. You always use the percentage mark, and then my following with some character. And along with the percentage mark, you could also use the minus sign. Minus sign means you're using left alignment, okay? And then you can follow that with the number to adjust the width of your output. The precision point will help you. Precision after that followed by a number will decide how many characters will be printed out of your string. And then finally, this L modifier is specified as a long type versus its integer type. It will make more sense once we look at the results, some examples. So here are some examples here. So if we use those common markers just to help you identify how wide the output is. Okay, it's not part of the grammar. Only look at the one in the middle. Percentage sign and 10. And then we follow with S, right? Assume that our S is hello world. Okay, so percentage 10s means our output will take at least 10 character wide. Okay, however, because our string actually takes 12 character, so that's almost like doing nothing, right? It still take 12 character, not 10. Okay. By default, that's right aligned. If we put the minus sign here, it is left aligned. But again, because our string is 12 character long, it doesn't make any difference. But now, if we increase it to 20, right, and now you can see the difference. So the entire output will take 20 spaces, and whatever space is not used will be filled out by blank. So there are a blank before the string, and then you print the program will print the string. If we add the minus sign in the beginning, we're left aligned. That means we'll put our string first, then fill up the rest with blank. Okay, this is like one of the grammar. The other thing is using this precision point, right? If we have a number after this precision point, that actually trim off our string to the number we ask for. So if, say, our string is 10, 12 character long, but we only want 10 of them, first 10 of them. So you can see hello world, right? It won't finish because we already reaching the 10 of them. Right. Similarly, if we do that on the left line, the same information, but then we just fill the space with either before the string or after the string. Yeah. Without the first number in the front, then we just only trim off our string. That means we only want the first 10 characters inside our string. Okay, make sense? Any question on this? No? Okay. The other part of the grammar is the conversion character. So those characters will happen after the percentage sign, right? Percentage D will print out the variable as an integer. Percentage O will output it as an octal number, and X is hexadecimal number. U is unsigned. C is a single character. S a string. E is a floating point in scientific notation, like something 1 or 0 point, whatever number, right? And the E, right? F is a floating point, fixed floating point, and G is either floating point or scientific notation, whatever shorter, it will automatically decide that. All right, let's take a look at some example again. So between the F and G, both of them will give you the form of floating point. But the difference is, if we're using the G, it will omit the tailing zeros. Okay, what does that mean? So if we print the same number, 5.432, the first case, if we're using percentage F, will give us the trailing zero, 3 of the trailing zero at the end, because by default, it will always print 6 positions after the position point. While the percentage G will not give us those extra zeros. It's always making things shorter, okay, essentially. Between the D and U, D is to give you the signed integer versus U is give you the unsigned one, right? So if, let's say, our integer is -42, and unsigned version obviously is 42. So you basically, essentially, you have to use the right conversion to print the right variable, right? If your variable is signed, so use the D. If your variable is unsigned, use U. then it will print out correctly. However, if you mix them up, if say my variable is an integer, but I'm using this u converter to print it out, it will give me a number which is not relevant. Right. The O is again octagonal, X is hexadecimal. Note here, the output will not have any prefix. Okay, like traditionally when we trying to differentiate the octagonal hexadecimal, we will put the like 0x in front of it, right, for hexadecimal. This won't be the case. It will only print out the one without the prefix. Also, if you use a capital X or capital O, well, no, not capital X. Only if you use a capital X, all the letters will be showing in uppercase. Okay. So when we use printf, a common mistake is mismatch of numbers, right? So in your first part of your string, you have to define like how many of those percentage sign you have in your string, then how many arguments you have to add after, right? If you have one of them, then you have to add one argument after. You have 10 of them, you have to add 10 of them afterwards as well. It will become very hard to read once you have a long, very long argument after. Often, if you miss one of them, obviously that program will break there. Okay, so instead of output, Scanf is the input. Okay, so it will do the reverse, essentially. So we have an input string, and then we will save them into variable rather than read them from the variable. Note here, the biggest difference here is those variable name has to be pointer. Okay, this is the limitation. You have to use pointer here. Argument 1, argument 2 has to be pointer. Cannot be just a variable. So let's see some grammar. You still use the percentage sign, right? It will ignore the space, and then you use percentage sign to decide how you're going to convert the number in. If you use a percentage with a star, that means that particular part will be ignored. It will not be converted into your variables. So the conversion character are very much similar to the one we just looked at. The only difference is this C conversion. That means you only read one single character. Okay. If you use this one, percentage C, it will not skip white space character. If it's a white space character, it will read that space character. To reaching the next non-white space character, use percentage 1s. Okay, that will give you the non-space character. Okay. There are more grammar. So F or E is also converting the floating point, and then the DOX could be preceded by L to indicate it's a long type or not, right? Okay, examples. So let's say we defined integer I, floating point X, and an array name. Now we're going to read inputs and then put those inputs into those three variables. Say our input is 25 space 45.32e minus 1 space, then Thompson. So those are three inputs, right? Because they're breaking up by the space. The first 25 will go into our percentage D, and we'll be starting our integer. 45.32 minus e minus 1 will go to our floating point, right? That will be going to the x. And finally, the Thompson will go to the name. Okay, again, one thing be careful about here is you have to use pointer here to store those, to retrieve those information. The reason we're not using pointer here is because this is an array, right? Array here is essentially just like a pointer. Okay, more sophisticated cases. All right, so this one, we will read percentage 2D into this I value. Note, in our all input, the number is 56,789, right? However, because we only taking the first two number, okay, putting into the D, our I will only containing those two digits only. Okay, it's not giving us the entire 5-digit and put it into the D, rather only the first two digits, because we have this number 2 before the D. Okay, then after that, the remaining 7, 8, 9, the remaining 7, 8, 9 will go into my F here, will be treated as a floating point. Okay, so that will be stored as 879.0 because it's a floating point number. Next one, this part will be stored into here. Because we have the star here, that means this part will be ignored. It will not be stored anywhere in any of those arguments. So we just ignore that one. And then finally, we are storing the first two character into our name array. Right? So the name array will have those 45 as a string rather than as a number. Right. Again, this example is quite confusing because we're using this digit before your converter character. The digit will only take that particular width and leave the rest of them to the next converter. Okay.
Can you explain again the purpose of the star before the D, please?
Yes. This one essentially ignores the next input. Okay, so the next part of the input should supposed to be this part, right? Because the 2D will take the 56, right? And the F here will take 789, and the percentage star D will take 1, 2, 3. However, because of this percentage sign, that means this number is not going to store anywhere in your argument. See, there are 4 parts in the conversion character, but only 3 arguments, right? That's because this one will not be stored anywhere. Just ignore it, basically.
Got it. Thank you.
Yeah. All right. So with those knowledge, let's look at an example, which is a simple calculator. So this calculator only takes inputs as numbers, and it will add them up and output the total of them. All right. So here you can see we're using Scanf to retrieve user inputs, and we will convert them into long f, right? Like long floating point. and we store that into the V. Then every time we receive this V value, we will add it to our sum, which starting at 0, and then we will add them up. And also, we will print the current total using this print t. Okay, /t here is the table sign, right? And then use percentage dot 2f, right? That means it will only print out the first 2 digits in your floating point. And yeah, and then a new line symbol. Okay, so again, the most important part with the scanf is to use the pointer. Okay. So in addition to those printf and scanf, we have alternative version of them. It's called sprint and sscan. S here means string. So that means instead of taking inputs or output from the terminal or to the terminal, we're taking it from the string. Anything else are the same. All right. Previously, if it's a printf, without this, like, you just go ahead with printf, output will go to the terminal, right? But now it will be saved inside this string. So when you initialize this string, you want to make sure it has enough size to store your output. For example, we initialize this string as a character array called name, and then we print this temp percentage d, and with the d we'll get the value from the n here. So that gives us the temp 42 inside our name array or our name string. Right? Basically, you print it using this particular format, and you store this output into this string array. String scan is doing the reverse. So we will getting the input from the string and then convert them into those arguments, right, based off the control statement. Let's say initially our string is temp 1, 2, 3, and then we can use scanf. We will ignore the first temp, and we're only taking the remaining part of the string and converting to an integer, store that into this integer variable, right? And this that will give us the result is the n will now contains 1, 2, 3 as a number, right? Just converting the string from like just each digit into a number. Yeah, by the way, this is very convenient. Before we have to use the A2F, right? Like ASCII string. If we are reading number from user's terminal, we have to convert them into a number. Right? Using this scanf, we can convert that just inside of this statement. Okay, so with that in your mind, now let's rewrite our desk calculator. In our previous classes, we have talked about using creating a desk calculator, which will take inputs like 1 space 2 space minus, right? Because we're using stack, so we push 1 into the stack, 2 into the stack, and then we use a minus operation between those two variables. And then we push a 4 or 5 into stack, and then using AND operation, and finally we're using a multiply operation on the top two variable in our stack. Right. So hopefully you still remember that.